Good afternoon and welcome to NASA's Wide Field Infrared Survey Explorer, also known as WISE, pre-launch news conference from Vandenberg Air Force Base. Joining us today are John Morse, Director of NASA's Astrophysics Division, Chuck DeVal, NASA Launch Director, Vernon Thorpe, United Launch Alliance NASA Program Manager, Bill Iris, WISE Project Manager, and Captain Andrew Fry, Launch Weather Officer, 30th Space Wing. We'll begin with some opening statements and then take your questions. John?
Thanks, Tracy. What I'd like to do is run over the broader context of the WISE mission and also talk about, at a top level, its science objectives, and to remind you that there is a science briefing coming up after this briefing. Let's get right to it and go to the first graphic and show NASA's astrophysics mission portfolio as it stands right now. We have Hubble, Chandra, and Spitzer along the bottom there. Those are great observatories. We also have Kepler in the lower left, which launched in March of this year, and Fermi in the upper right, which launched last year, both returning their science results. There are 5 internationally led missions on which NASA is a partner. And we also have 4 Explorer missions, XTE, GALEX, SWIFT, and WMAP. And the Explorer program is one of our most important aspects of our flight program, and it does entail the smaller missions along with the larger missions, like Hubble, Spitzer, and Chandra. Now, these missions cover the entire electromagnetic spectrum. Now, if we go to the next graphic, we see that we're adding WISE, and WISE is shown here not because it's very large, but in order to emphasize its newness. WISE joins the largest fleet of astrophysics missions that has ever been flown and that astronomers will use to make new discoveries. Now, WISE is a 40-centimeter telescope. It's cryogenically cooled to minus 430 degrees Fahrenheit. It has 4 state-of-the-art infrared detectors. It'll take over 1 million images during the course of its 10-month mission. And so now, why don't we contrast a little bit between the visible and the infrared and begin to delve into why we're doing WISE. On the next graphic, what we see is how the Milky Way and the sky, which is centered on the Milky Way, appears to the visible eye. The Milky Way is the band across the middle. It's diffuse. You could see the galactic center in the middle, and there's other galaxies like the Magellanic Clouds, those smudges on the lower part. This map is dominated essentially by starlight, and you see how patchy the Milky Way appears due to the obscuring dust that permeates the galaxy. However, in the infrared, on the next graphic, we see how much different the sky appears in the infrared, and this is a new tool for astronomers to use in order to examine the cosmos. Now, this infrared map shows how the Milky Way is a very flat disk where material concentrates. And then you can see the tenuous clouds, some nearby, some far away, which are the sites where new stars are forming. So in summary, this new sky map that WISE will generate is hundreds of times more sensitive than the previous maps. It will represent the infrared motherlode that astronomers will mine for the years to come, and then they'll be able to go through this map, identify interesting targets for follow-up observations with observatories such as Spitzer, Hubble, Herschel, and eventually SOFIA, which is in the air right now, I might point out, and also the James Webb Space Telescope, which will be launched in the middle of the next decade. And so with that, let me turn it over to Chuck.
Thanks, John. Good afternoon. I'm proud and privileged to be here today representing the men and women of the Launch Services Program. I can tell you that the launch team is ready. We have been through all of NASA's reviews. We do have one review remaining. Tomorrow morning we're going to meet with the Air Force and get a go, hopefully, from the wing commander. But we have a busy next 40 hours, and I'll touch on that a little bit. But what I wanted to describe today is how we got to this point. I have a video depicting some of the processing milestones that we've achieved so far, if we can roll into that. This shows the booster being hoisted into the mobile service tower. There's a shot of the RS-27 main engine that provides about 200,000 pounds of thrust at liftoff. This is a shot of the inner stage, which rests atop the booster. It helps span the first and second stage. The second stage will be hoisted and set in between that, where the engine bell will reside in that inner stage. Here's one of 3 solid rocket motors being hoisted up. This configuration is a 7300, where we have 3 groundlet solid motors built by Alliant Tech Systems. That's the second stage coming in. This was on October 23rd. It's got an Aerojet engine. For this mission, that engine will burn twice in order to get WISE into its proper orbit. There it is, setting down into that inner stage, if you can visualize that. Here's the spacecraft canned up, rolling out on November 20th. Spacecraft weighs about 1,460 pounds. That's a direct mate adapter that allows the team to rest that atop the second stage. Torque it down. Some of the platforms allowed to move to bring the fairing, the 2 halves of the fairing, in. This was just before Thanksgiving. There's a shot of the spacecraft on top of the second stage with 1 half of the fairing on. Obviously, in a clean room environment with WISE's telescopes and instrument, it's vital to keep that area in a clean room environment. And there's the launch decal. So going into the next 40 hours, starting tomorrow morning, we do have the range review, as I'd mentioned. Following that, because we are going to hear we've got some challenging weather ahead of us, we're going to have one last tag up and see what the forecast for Friday would bring. This will allow the WISE spacecraft to disconnect their cryogenic operations and commit to launch. So if we are successful with that, we do have another weather brief at 3:30 tomorrow afternoon, which will allow the mobile service tower to retract back. We plan to do an early fuel load into the first stage. That plan is for 7 p.m. Tomorrow evening versus doing it during the countdown on Friday. That aids in winds. If we were to have high winds, having that stability in the booster helps us handle a higher wind condition. Given all that, the tower would be rolled back at 8:30, between 8:30 and 10:30 tomorrow evening. So if we get past those, we start on console Friday morning. The management will come on at 2 in the morning. We are in a 60-minute built-in hold at that point. We then transition into our terminal count for the final 3 hours. We have one more weather brief that says we are able and willing to load liquid oxygen into the first stage. That's at T-minus 75 minutes. If we get past that, we do an engine slew check with 30 minutes to go. We have planned built-in holds. If we get behind in the count, we can use those to make sure we hit the T0. T0 is 6:09:33 Pacific time. We've got a 14-minute, 18-second window. We have on the range the 11th and the 12th if we need it. And you'll probably hear from Bill Iris how complex this mission is. So we have a 2 days on, 2 days off kind of posture. So if we were to count down and not make the 11th and 12th, we would have to stand down for the 13th and 14th, let them go do some cryogenic operations, and we'd be back after that. So it's quite complicated, but we are poised to make an attempt and get through our next 40 hours, and looking very much forward to it. I'll turn it back over to Tracy.
And now we'll go to Vernon Thorpe.
Afternoon. United Launch Alliance is proud to be supporting NASA for the launch of the WISE mission. This will be our 7th NASA launch of the year, coming on the heels of some other well-known missions like NOAA N Prime, Kepler, LRO, LCROSS, and we've also supported NASA on some Missile Defense Agency missions this year as well. And this is a great time to be part of ULA. Just last week, we launched a Delta IV from the Cape. We launched the WGS-3 mission for the Air Force, and that marked our 36th launch in 36 months since ULA was formed. The WISE mission, we hope, if we launch in the next few days, will actually be the 37th mission in 36 months. We have until December 14th to achieve that milestone, because December 14th of 2006 was our first launch as United Launch Alliance. The credit for all that goes to all of the incredible people at ULA, as well as our government partners like NASA, who support us on all these challenging missions. We've been using our entire launch vehicle family, all 3 of our families, over the last 3 years. We've been launching Delta IVs and Delta IIs and Atlas Vs, and we've been launching off of both coasts, as you know. And I'm happy to say that more than a third of those missions have been performed on behalf of NASA. Counting WISE, 14 out of 37 missions, more than a third of them, have been done on behalf of NASA. In just 2009 alone, we've launched 8 Delta IIs, 4 from the Cape and 4 from Vandenberg. And I would now like to tell you briefly what tomorrow's flight profile, or what Friday's flight profile, is going to look like. We're using a Delta II 7320 configuration. That's a Delta II core with 3 SRBs on the back end. We have a 10-foot composite payload fairing protecting the spacecraft. And after liftoff, the 3 solid motors will burn for about 99 seconds. Then we'll jettison those. The central engine, the core engine on the first stage, will continue to burn until about 4 minutes into flight. After we run out of propellant on that stage, we'll separate from the second stage and we'll ignite the upper stage engine for the first of 2 burns. About 5 minutes into flight, during that first stage burn, we'll jettison the payload fairing, because we'll be clear of the atmosphere. About 5 minutes later, 10 minutes into flight, we will complete our first stage burn, or our first of the upper stage burns, rather, excuse me. And then we have a 40-minute coast period. Following the end of the 40-minute coast, we light the upper stage engines one more time, very short burn, only about 8.5 seconds. And then we will use that burn to inject the WISE spacecraft into the orbit it needs to get to. And we'll separate the spacecraft from the launch vehicle just a little bit less than an hour into flight. And that's all I have. Back to you, Tracy.
Thank you. Now, Bill Iris.
Thank you, Tracy and Vernon. It's a pleasure for me to represent the WISE project team. Jet Propulsion Laboratory, Ball Aerospace Corporation, and the Space Dynamics Lab have gotten together to produce this beautiful instrument. I can report that the instrument and the satellite is ready to go, that the flight team is ready to go, and that the operations team is ready to launch and operate WISE. It's going to be a very busy time when that 55-minute point after launch occurs for WISE. We will turn the satellite on at about 6 o'clock tomorrow morning, do some software loads and some checkouts, but we'll be sitting quietly waiting for the separation signal from the spacecraft computer. When that happens, we have lots to do. The first thing we'll do is phone home. We'll be in our circular orbit, and the WISE satellite has a low-gain antenna that's showing up on top here. That low-gain antenna will communicate with the relay satellites above us, and they should acquire a signal fairly rapidly. We expect anywhere from a couple of minutes to maybe 5 or 10 minutes, depending on how the WISE spacecraft is tumbling when it separates from the launch vehicle. We expect it will tumble. The satellite is going to be in a tumbling mode due to the fact that the separation system is not perfectly symmetrical. We expect that, and the software in the satellite is designed to cope with that. Its objective is eventually to take the solar panel and point it at the sun directly, so that the batteries that have been discharged during the flight can be recharged. About 20 minutes after launch, another very important event occurs. As Chuck indicated, this is complicated. It's not complicated for us because we're used to it, but we have 2 solid hydrogen cryostats that contain about 40 pounds of solid hydrogen. They've been warming up for about a day, and we need to vent those tanks so that the telescope and the detectors that WISE will use cool to their operational temperatures. That will occur automatically at about 20 minutes after launch. And then we have one last important task to perform, which is to get our bearings with respect to the visible sky, in this case. We have 2 star trackers on the back side of WISE, shown here. Let's see here, over here. One there and one there. Those star trackers will image the visible sky, and they will determine where WISE is pointed inertially. And with our knowledge inside the computer, we're going to be able to orient WISE so that it faces directly out from the center of the Earth and is in its final survey orientation in its orbit. And I have an animation coming here which illustrates that orbit. There it is. It also illustrates our model, so you can see the various features of WISE. You see a lot of plumbing on the upper part of the instrument on top there that is part of our complication. So here we are, WISE in orbit, pointing outward, scanning the sky in great circles repeatedly, about 5,700 pictures a day. And this orbit was chosen and optimized specifically to do an all-sky survey in 6 months, so that as you see, as the Earth rotates around the sun, the orbit plane rotates with it. And so that after 6 months, the entire sky can be seen in this orbit, and we will have completed an all-sky survey at that point in time. So here we are, we're oriented in orbit, we've got our initial bearings, but we still have lots to do. This occurs after about a day. There's another month of work to do before we can start our all-sky survey. We'll start with a cover on the telescope to protect it from any possible deviations from the normal plan that we have. We'll calibrate our attitude control system, and we'll get comfortable with the sequences that we will use to eventually survey the sky. After 16 days, we'll remove the cover and expose the telescope of WISE to the infrared sky. That will require further calibrations. This will be the first time the WISE's eyes, the eyes of WISE, will see the infrared sky, and it'll take about 2 weeks to get those calibrations completed, after which time we will begin the survey that WISE will perform. So I'm looking forward to this, and we have a couple videos to step back to the kind of our life here at Vandenberg Air Force Base for the last few months. This video that you see now shows the flight payload adapter fitting being installed. This is the actual hardware. The little red hammers you see is the separation plane between the spacecraft and the launch vehicle. Here you see WISE when it arrived, being lowered onto the separation springs that I referred to. These are what's one of the 3 springs that separates the satellite from the launch vehicle. And so there we have the flight spacecraft and its solar panels being mounted on the spacecraft. Our last step here at Vandenberg Air Force Base was to package WISE into its transportation container and move it out to the launch pad. And that was a pretty exciting event that I think is shown here in this video. You see the container being lowered on top of the double-bagged spacecraft very carefully. There's not a lot of room on the edge there, so we've got lots of care being taken there. There we are rolling out of the high bay here at Vandenberg on our way to the launch pad. So we're really excited about this. It's it's a matter of just the weather now, and Captain Fry is going to tell us how good the weather is on Friday morning, or not.
Thank you. I am the launch weather officer for Delta II WISE. The launch weather officer's job, commonly called the LWO, is to lead the launch weather team to make the final, make the go, no-go call for weather. We have constraints on both sides with the Air Force and the range side, as well as the ULA or customer side. Both are designed to protect the satellite and get it into orbit, and to protect the public in general that the rocket is successful. So we can go to the satellite loop that we have currently. Right now you can see the weather on satellite rolling towards the central coast. You can see a lot of the energy going up towards the north, but the entire band extends down well to the south and the west, and that's slowly making its approach towards Vandenberg. Over the next day or so, it'll continue its march, and the rain should start falling here at Vandenberg tomorrow around noon or thereabouts, and then we'll continue with light rain all through the count towards T0. The launch forecast for tomorrow calls for thick clouds in the area, and thick clouds is one of our constraints. We're not allowed to launch a rocket that's through a cloud layer that's greater than or equal to 4,500 feet thick, with temperatures between 0 and minus 20 degrees Celsius. You can kill the loop now. With those clouds moving our way, even if the rain showers decrease or diminish, those thick clouds will remain, and that's our main area of concern. We issue what's called a probability of violation, or a POV, and a POV tells us how likely we are to break our constraints, how likely the weather is to negatively impact the mission. Our POV right now is 80% for those thick clouds. Some other associated constraints that we're worried about is called are called disturbed weather, which has to do with any kind of instability in the area. We are worried about that with some moderate rain showers. Moderate rain showers are also a constraint. Any rain that would be above the 10,000 foot level is also a constraint. Luckily though, Delta 2s in December are traditionally hampered by winds out here on the central coast. At this time though, the winds are looking to stay below the 20 knot level, which is well below our constraint of 26 to 30 knots for T0. So we're not looking for that problem. However, with this system, it'll move through, once it gets here, it'll move through during the day on Friday. Another system is quickly approaching behind that, and that will cause problems for a possible 24-hour scrub if that were to occur. If that 24-hour scrub occurs, the same type of weather happens. However, you get the cold front type of weather that comes along with it. A few cumulus clouds, heavier rain showers, and wind. So you tie all those together and you have another 80% probability of violation for Saturday. Much of the same continues on Sunday. The weather finally starts to clear and break up for Monday as ridging and high pressure move back into the central coast, giving us fair skies and a light offshore breeze for Monday and into Tuesday. But that's what we're worried about right now for Delta 2Ys. The launch weather team will be on console throughout the count, evaluating all the weather data that's coming in and giving either the final go or the final no-go call for weather. Back to you, Tracy.
Thank you. We will now take questions. Please state your name and affiliation and to whom your question is directed.
Janine Scully, Santa Maria Times and Lompoc Record. Can you further explain when the clock starts on the 48 hours with the WISE constraint and when exactly that goes into effect?
Yeah, I'll take that. You're talking about the cryogenic servicing constraint. It starts when we disconnect the cryostat at about launch minus 19 hours. At that point, we disconnect cooling, helium cooling from the cryostat, and the hydrogen and starts to warm, and we can allow it to warm for 2 days before we have to reconnect and cool it. That cooling takes about 2 days, so we have a 2-day on, 2-day off, 2-day on cycle, which is not common for a launch like this. And so we're working with the NASA people and ULA people to get those cooling days on rainy days and the launch attempts on clear days.
Nora Wallace, Santa Barbara News Press. Mr. Morse, the wow factor of the science in this seems pretty obvious when you start reading about it, but can you explain in perhaps more layman's terms why this mission is so important for people on the ground?
Sure. We'll start with the importance of the infrared band to begin with. And in fact, I would encourage you to make sure if you're around to ask the scientists later. They love to tell you about WOW. And the infrared is important to us in astronomy because it shows us where a lot of the cool things are in the universe, things much cooler than stars like the sun. And as you saw in the sky maps, the universe looks much different when we're at infrared wavelengths. And the wow factor of WISE is that we're going to go much, much deeper, 100 times deeper in some wavelengths and even 1,000 times deeper in other wavelengths than we've ever gone before. We're going to see in the solar system 100,000 new asteroids or more. We'll see new structures and targets in the Milky Way, and we're going to see hundreds of millions of objects around the sky and open up the extragalactic full sky survey. And this is going to support our other missions that we have up there flying now and will be flying in the future. And so not only is WISE going to be a fantastic science mission in itself, but the support it will give to other missions in the future, following a long legacy of previous sky surveys at other wavelengths, is going to be fantastic for astronomers to use. So WISE's legacy could literally last decades.
Are there any further questions? With no further questions, this will conclude our pre-launch news conference. Our next event will be the WISE Mission Science Briefing, scheduled at 1:45. For more information on NASA's WISE mission, go to www.nasa.gov/WISE. Thank you for joining us.